Hello, everyone. So, one of my favorite books is a book called How Stuff Works. How many people have heard of that book? How Stuff Works? It's about how stuff works in the everyday world. Motors, engines, stuff like that. And what I love about that is I just love to understand how stuff works. And that's what we're going to do today. In my session, we're going to pull back the cover, open the lid on the engine, and look at well, remember that Plagentic app that we talked about in the keynote? We're going to look at kind of the mechanisms underneath that app. And specifically, we're going to look at what people talk about RAG. So we're going to understand what is RAG, how is that driving the app, how does that relate to the database, what does Yugabyte do, and then also getting the data, that unstructured data, into the system so that AI can even analyze it. That whole pre-processing pipeline, we're going to look at that as well. And then I hope that you can leave from this session with like an ability to say, okay, I know where to go look and how to do this myself. And in a matter of about an afternoon, you should also be able to build an app kind of like this. So when it comes to RAG, first of all, like why? Why do we need RAG? What do vectors have? How does that relate to RAG? What does Yugabyte do for that? And then what about all this data that we're feeding in to drive the AI? So like RAG's let's look at that unstructured data. And then just let's demo it. So let's see how Yugabyte functions in this whole context in the solution, and we'll go through some demos. All right. So we'll go step by step through these. So why RAG? Okay. So let me ask you this: if you went to ChatGPT today and asked this question, this one simple question, why do your customers call your company, and what's the most common question that they get? Would ChatGPT give you a good answer or a bad answer? And that's a rhetorical question, because ChatGPT doesn't know anything about your tech support. They don't have access to your CRM. They don't know what's going on behind the scenes, right? So the answer that they're going to give you is just totally synthetic. It's going to be their best guess. And so for enterprises, where RAG is really, really useful is to get access to your kind of enterprise private data that's behind your firewall, and still enable AI to make sense of that data and be helpful and provide value to your customers. All right, so enable LLMs to utilize that private organization-specific info as context for a response. And we're going to explain what that means. LLMs, this also, RAG, and incidentally, is also used a lot of times for chat history and for using the history to inform future responses in a chat. And you'll see why. So that's the why we even use RAG. It's actually absolutely critical for you in the enterprise. So this is the simplest possible explanation of how RAG can work, okay? So when it goes to runtime, somebody comes along and says, I got a question, and I want to ask your enterprise this question. And you can't just feed that question. We'd like to feed that question straight over to the LLM. But in addition to just feeding the original question, before we go to the LLM, we do a search. In your application, we have the application go and search some set of index documents and retrieve a few excerpts and pass that along with the original question as context. And so the actual question, the actual prompt you send to LLM is that original question plus, hey, use these excerpts, these little document chunks to help inform your answer. Then the LLM, kind of acting as a black box, puts on its knowledge cap and says, okay, let me answer that question, but I'm going to use those document excerpts, which are your enterprise's private data. Okay? So this is, does that make sense? Kind of the fundamentals, it's actually really simple. The complexity then, or some of the challenge is, you write the app, that's kind of at runtime, but also how do you prepare your documents, your data, those Plagentic coaching guides, the PDF documents, the log stream. How do you get all of that into the database in a way that's easily searchable so it's ready at runtime efficiently for that runtime query? Okay, so let's look at how Yugabyte plays into this. Let me see if I can. All right. So the first step then is setting up kind of the schema and setting up the environment. And the beauty of Yugabyte is it is completely Postgres standard. This is exactly Postgres PG vector notation. Here we're creating a table just like we normally would, but we add one additional field. You see that third field of a special type that's a vector type. So you've got the ID and maybe the text that's your document, and then you've got a vector that describes that document. So we're going to set up that table. We're going to set up an index against that vector. So this is all PG standard. And then when it comes time to ingest your data, ingest those 10,000 PDF documents, and chunk them up. And we'll talk about that whole processing pipeline later. You simply insert rows one by one right into the database. And we also insert vectors with each row. And those vectors are generated by the LLM. So we'll call out to the LLM and say, hey, vectorize this document. That's called embedding. And that embedding kind of is like some set of magic numbers that somehow describes the document at hand and is used at runtime to do a similarity search and get back the top documents. In this example here, we're using, again, Postgres standard select kind of notation, but we're doing some special notation here for a similarity search to get in this case, top 10 document rows that are similar or closest in vector to whatever it is I'm searching for. So in this, we're going to search for excerpts that are similar to the prompt. Okay, so if the user's asking about tech support, we're going to get the top 10 document excerpts that are related to tech support. So basically, the good news here is, sorry, I'll go back and just kind of summarize. Yugabyte is Postgres standard. You can go to any document and about Postgres. You can look at any document about PG vector in Postgres, and kind of that just works directly over as you move over to Yugabyte. Except, and if you look at the bottom half of the slide, we've slid in our own HNSW indexing layer. We support for these different kind of distance functions that give similarity. And we've kind of, really what we've done is we've turned the Postgres, we've used the Postgres syntax, but under the hood, we've made things distributed so they're scalable and they're resilient. So all of our vector capabilities operate at that level of scale that Brad was talking about, petabyte scale. Actually, we've supported, we'll talk about some of the innovation we've done just recently and happy to announce in terms of scale, but we're fully scalable and fully distributed and actually highly resilient to failure as well. All right, so this actually relates to why Yugabyte, because we know there's other options out there. If you went to a specialized vector-only database, that's definitely possible. If you went to a OLAP system, we see some people using kind of their data warehouses and running RAG and AI off of that. That's certainly possible as well. And there may be a role in certain applications for those kinds of solutions to play. But what's unique about Yugabyte's approach is first, we've got this pluggable vector indexing technology. Enables a lot of choice and a lot of flexibility. So if you want like phase as the library, we'll give you phase. If you want HNSW lib instead of our library, we'll give you HNSW lib. Today we're using usearch as the indexing library. That's an option as well. So we kind of got embrace the openness, embrace the flexibility, be agile, enable to use the latest and greatest. Because this is in a relational database. Thanks. All right. Okay, we're going to switch over here in just a moment. Also, we're in a relational database that's consistent, normalized, and totally ACID. So a transaction is a transaction. We're not in any kind of eventually consistent mode. We've heard kind of concerns from other customers where data can get desynchronized. Like sometimes you're loading some documents and vectors and metadata in one place, like if it's in a separate vector store, but then you've got that same metadata in a relational database, and now you've got two different systems, and there's an opportunity for desynchronization. And when you're trying to run a load data and you're doing a query at the same time, all of a sudden you can give bad results. And you avoid all those problems by kind of having unified relational and vector and your documents all in one place, like in a Yugabyte. When it comes to people we also hear people who are using OLAP systems, that can work great, but you're talking generally about longer response times, right? Those are usually columnar databases. You're talking about kind of OLAP, analytical databases. That's not always appropriate for a transactional system. Sometimes you also have data synchronization issues there, because it is an OLAP system. You've got maybe your source data, maybe it's going through an OLTP, and it's got an ETL and crawl all the way over here to get to your warehouse, and then you do your RAG or your vectors against that. That whole time pipeline can also cause desynchronization or data freshness challenges and issues like that. Yeah. So ultimately, I mean, I'm biased. I'll be the first to admit that. But we do see a lot of customer feedback saying getting all of this into a single consolidated database just makes life easier. From an application point of view, synchronization, those issues go away, easy access to all your data, and also easier to operate because you're just operating one system rather than multiple systems. All right. Okay, so let's have a look here. So let's look at some code. So when it comes to, I just want to take you through some code, and this is easily accessible on our website as well. But I'm going to assume you don't know anything. And the first things we do here is just set up the application itself. Here we got an example here. This is going to be a simple RAG example. This is just about the simplest you can possibly get. We're going to install Python, kind of get a virtual environment. In this particular sample, it runs with Llama Index. That's kind of a framework in the Python environment. And we're calling out to Python using the scicopg, or calling out to SQL with a little Python. We're also going to use OpenAI. So we have an API key here as well. A few simple commands to do this even on your laptop, just to run Yugabyte. You don't need a server. You can do this I do this on my own Mac. And in a matter of like 4 or 5 commands, you can download, start up a little mini cluster, and then in this case, we're going to create the PG vector extension that enables that vector data type. And we're creating that simple table that has an ID here, a little bit of excerpt of some text, and the vector that describes it. So we've basically installed things and got our schema set up. And then there's 2 stages. One is the pre-processing, where we're going to load all of our kind of knowledge bases into the vector store, which is this table right here. and then there'll be the runtime where we actually handle a query. So that pre-processing, here we've made it fairly simple. It's as simplistic as it can be thanks to Llama Index. It's really this one line here that's the simple directory reader. So we're connecting to the database. We're going to read from the ./data directory. And then we're going to automate, and Llama Index makes this pretty easy. It's going to convert all of those document chunks that were read and convert those all into vectors. And then we're going to store those vectors in the bottom here from this memory-based vector list. We're going to copy that, ultimately insert it into the YugabyteDB using the insert statement there. Right, so standard Postgres, we're just loading all the documents and vectorizing them and storing that all into Yugabyte. So at this point, we've got our knowledge base, and it's ingested in little chunks in our database, and it's ready for similarity searches. So this whole interface is a user chatbot. It's kind of like an Ask My Knowledge Base RAG application. Ask my data some questions. And so here, don't know if you can see this, but we're going to basically get some input from the user, and we're going to turn that into a vector. Then we're going to do a search here, where we're going to search from our knowledge base. It's in the database, do a vector similarity search, get the 5 or 8 or 10 excerpts that are most similar, use that as a context, and basically pass that all to the LLM and say, hey, Mr. LLM, this is the key part. You are a helpful assistant. Answer questions using the provided context if possible is what I've added in the demo. So let's actually just watch the demo. And here I'm going to run the demo twice. Once with no context. There's no answers. And I'm going to give this an impossible question. Ignore the error message. The question is, what's my wife's name? And what are her hobbies? There's no way ChatGPT knows the answer. And you saw the answer. The context provided does not answer the question. Basically, ChatGPT is saying, I don't know. Then I run it a second time where I preload it with context, and it's retrieving some context. And one of these 5 or 6 pieces of context, I planted an Easter egg in my data, naming my wonderful wife, Lily, and some of her favorite hobbies. So you can see that that's my private information. For you, it might be your enterprise's private information that kind of specifically enables an LLM to answer questions about your own enterprise's private data. So that's kind of a very simple RAG in a nutshell. In just a matter of 3 slides, maybe 100, 200 lines of code, we saw how RAG works and how Yugabyte enables that under the hood with its vectors and its vector search capabilities. All right, so some common questions I get. Let's say you go home today and you say, I want to do this myself. Some very common questions I get are, well, I don't have access to OpenAI. My company doesn't allow it. I don't have a credit card, whatever it is, I'm not able to do that. So there are options. One option that we sometimes recommend is download a local LLM. Ollama works great. DeepSeek can work. We've got sample code on our website that illustrates exactly how to do that. Another question is, what version of Yugabyte supports this? And that's a great question. Some of our customers are not yet fully deployed on the latest 2025.1, but that's the answer. So our June release from this year is kind of the minimum requirement to be able to do what I just showed on the screen. If you don't have a cluster, I still encourage you to go to our website. You can do this all on your own laptop. And you can do it also for free. Either on your laptop or through our managed service. You can use a free trial on our managed service. Everything here that I've shown, just available on our own docs website, simple URL. Go there if you want to try it yourself. All right. So that's kind of your first part, basic RAG. But we used Llama Index to make some parts of that coding easier. Llama Index is just one of the different app frameworks where we've done some integration. You see a whole list here like LangChain and Unstructured and some of the cloud vendors. We're well integrated as a Postgres slide-in, and in many cases, we're also a first-class citizen on those partner websites where once they've integrated with us, they get some more advanced capabilities. So definitely check out your own favorite language-specific kind of orchestrator or framework. A lot of times they help with the unstructured data, the pre-processing layer, or work with our cloud partners. And there's a lot of goodness there, and we are thoroughly integrated and have lots of sample code also with those cloud partners. So what we looked at when it came to code was the open Postgres kind of PG vector standard. That's kind of on the far left here. And then as you go to production, as Karthik mentioned, because we're sharding these vectors, we're sharding the index, we're distributing things, we are designed for scalability on the vectors front. And we're designed for not just scalability, but also resilience. I'm super happy to announce that we've actually published just in the past week that our support for 1 billion plus vectors. So we've proven through our test results that we achieve sub 300 millisecond latencies with very high 95% and higher accuracy at that high scale. And that's scale we think was limited only by, that's like the biggest data set that's available on the public internet. We're designed for even more scale than that. And so the whole system that we've built here is built for this high scale with great performance so that you can get to production. And it's not, and then as you heard from Brad, he's running some things at RF3, RF5, RF7. Our vector capability is fully aligned to all of that kind of redundancy, multiple copies of every vector, and the ability to kind of survive any failure as a result. So we got some great stuff there. Now that's the basic vector capabilities that really power that similarity search in a RAG workflow. But I kind of glossed over one very important line of code, which was about the preparation, the pre-processing. So let's go kind of in part 2 of this session. I want to spend some more time. Now let's talk about what this pre-processing pipeline is, and we can talk about what we're exploring right now to help simplify that whole workflow. And then let's look at the specific example and the actual code in more detail. And you got a glimpse of this in the keynote with that Plagentic app. Let's take it apart and go a little deeper. So what is the pre-processing pipeline? It's this picture. You've got a bunch of different data sources. And now let's imagine a bunch of PDF files. And these PDF files are 200 pages long and very complex. Chapters, sections, maybe some graphs and diagrams inside. And you're trying to analyze this data because it's part of your company's knowledge base. Maybe it's PDFs, maybe it's your wiki pages, maybe it's a support ticket, a call log, whatever it is, a telemetry line. There's a lot of data here that's typically unstructured. So the first step is just kind of trying to maintain that structure, partitioning it properly, maybe chapter by chapter, parsing that out, and then getting meaningful excerpts that are going to be used in those similarity searches, right? So that's the chunking part. Then creating a vector embedding around each chunk, and then finally feeding all of that into the data store. So there's a lot of work here. I cheated in my earlier sample because I made my directory of files all kind of super simple little paragraphs that were already self-describing and easily chunkable. But the real world's often not like that. The real world often involves, first of all, dealing with data that's sitting, that's usually in the past you didn't have to analyze. Usually this is usually new, high volume, unstructured data. That means different types of data. Now we've got text, audio, video coming from different locations. Is it in your cloud? Is it on your intranet? Is it coming out of this app? So it's coming from different places, and you've gotten more file formats to deal with now. Doc files, PDF files, log files, JSON files, JPEG files, all kinds of file formats. It's a huge diversity of data now that people are looking to drive into their AI system over time. Right? So that's a big challenge. That's maybe a long-term challenge. Initially, you might start small, but over time, you can imagine your AI system is going to be very hungry because it's only as good as the data you're feeding it. And so this is one challenge we see. Scale, diversity of data, and then the complexity of this pipeline can cause a time to data availability issue. If it takes time to process, and you've got to parallelize and spread it out, and then move it from each stage to the next stage. This can take minutes or hours depending on the scale of data you're loading, and that freshness time can be an issue as well. And then when you have a system that's distributed and complex like this, now you have operational needs. How do you monitor that system? How do you secure every stage of the system? So these are some of the challenges people are dealing with when they're working through this unstructured data. And the great news, and you heard a brief mention to it at Nikhil's talk when he talked about a Yugabyte's RAG extension, is that we're looking at and exploring taking what you're dealing with today, this whole pipeline, as your responsibility, turning that largely into our responsibility. Offloading the work and the effort from your application code, like where that sample code you saw earlier, the application had to deal with and use tools like Llama Index in that example to do some of this processing work. We'll run that as part of an extension of our database. And now, you're probably wondering, like, how does that work? Like, it'd be great to let you take that responsibility, let you do the glue logic, the integration work, and the support for the different kinds of data sources and data types and data structures, all that. But then how does that work? Because you need the flexibility to be able to do it all, right? And so this is where our embracing of the Postgres ecosystem really plays to our strengths. Because with Postgres, there's already extensions to bring in data from the cloud, to bring in data from Iceberg or from Parquet, or bring in log data at scale through DuckDB. Like, there's extensions for just about every kind of data source and every kind of data type that you want to bring in. So we're actively, and that what you didn't see in the demo, but we're using like a PGNet extension to read certain data out of a cloud kind of storage bucket. And there will be many, many data sources. That's kind of a universal access broker that's at the very start of that processing pipeline. And then within our database, each stage of this kind of pipeline, we have kind of pluggable components to leverage other tools in the ecosystem to do some of the heavy lifting work. So leverage unstructured or LangChain or Llama Index in this case, for that partitioning parsing. Leverage other tools to do the chunking, and then plug into any which LLM, or you choose your own, provide that for the last vector generation stage. So really, this gives you gives us the accountability, relieves you of work, and gets you kind of the optionality that you want. Kind of another way to look at this is, whereas today you're dealing with vectors directly, and you're in your code having to pre-process these documents and also do the vectoring and kind of load all the data into Yugabyte, the future can look different. You don't have to deal with that. You just provide us with the documents. You provide us with a pointer to that directory or that URL, and we'll take it from there. Instead of you operating and integrating these moving parts, we're doing that, and it's just one system that you're interacting with, one kind of turnkey, pre-integrated Yugabyte system. And instead of you having that homegrown pipeline, it's really something that's integrated with the data store. And finally, when it comes to code, really what this ends up looking like is, instead of hundreds or sometimes thousands of lines of code that we've seen people deal with to process that unstructured data and all that tooling that gets integrated into the application, it moves into a single SQL statement, kind of like one insert statement that inside of your app, and really turning this over to Yugabyte. Kind of one statement with some configuration options to specify the behavior for each stage of that pipeline. So kind of just summarizing what we've talked about here. We looked at how RAG is built. What does RAG mean? How does a simple RAG start off just utilizing vector capabilities in a database? And we saw that it's not that complicated, but there are multiple stages of that whole process. Then we looked at kind of where Yugabyte's going in terms of making the processing of the access and the whole pre-processing of that unstructured data a lot easier and a lot simpler, so that you can focus on your applications and we can focus on the data part. Overall goal here is just to enable you to build your apps quicker, more reliably, and get to production. So in terms of where to go next, I encourage you to go to our website, sign up for kind of our mailing lists. You will see blogs regularly about AI. We just launched the blog about our ability to scale. You'll see blogs about this pre-processing pipeline. And you'll see just lots of great information there. Go to our docs website and try out a cluster, whether it's on your own laptop or on our fully managed service, or if you're a self-managed customer already. Try it out. It's really simple and easy. And in an afternoon, you can easily get started and do everything I just talked about here today. All right, thank you very much.
Yugabyte is Postgres standard, right? So how closely will you keep up with the latest PostgreSQL version, and how often will updates occur?
Yeah, so we are Postgres standard, and we are branched from the Postgres database. So we take the Postgres mainline source code, and we use that as our language front end, and we last branched at PG version 15. And that's actually been integrated into our own release, actually earlier this year, so we are fully supportive of kind of the PG 15 syntax capabilities. And then it's our intention to regularly kind of refresh and get back to the latest PG. I think we're going to do that on a frequency of roughly every 2 to 3 years. I don't remember our exact plan for the next version. It's either 18 or 19. So our intention is we'll refresh again at PG 19, and we'll just be on a regular cadence like that.
Do you support spatial data types?
Do we support spatial? So this is like PostGIS kind of coordinates, XY coordinates, that kind of thing. While you would wish that, we don't, unfortunately, yet support the PostGIS extension. We're close. You can see vectors. When we did all this work with vectors, I said to myself, vectors, coordinates, are we talking about something highly similar here? And there is a lot of similarity. but officially we're not there yet with the Postgres. So it's in our roadmap, but not available yet.
The RAG demo calls OpenAI online, or is there a local package?
This RAG demo calls OpenAI online. And that's OpenAI, I think, is only available as a SaaS service. That said, there are options to bring it local, as I described. And some of the cloud partners also here provide dedicated private LLM instances, and that can be another way to get an LLM in a more private manner.
So along that vein, this private data remains private, or is that to also pass to external AI models like ChatGPT?
So yes, data privacy is a big concern. We hear this a lot from enterprises, especially if there's, imagine, customer data, maybe medical data. Maybe you don't want to send that over the public internet to an OpenAI, for example. So multiple options for how you solve that problem. One is, as I described just now, work with the cloud vendor, get a private, dedicated, deployed instance of an LLM, but it's in a data sandbox, so to speak, which could be your enterprise's private data sandbox. Another option is to use a local LLM and run that entirely within your own either private or on your VPC or private environment in a cloud.
Are there any plans to integrate with Gemini or Grok or any of these other LLMs?
We pretty much integrate with all the LLMs. So the example I showed might have been OpenAI, but if you go to our website, you'll see examples showing integration with Gemini, integration with Azure, pretty much with any of the, with Anthropic, any of the LLMs that are out there, you can use with Yugabyte.
Do you think RAG is the secret sauce for LLMs to actually provide great answers?
Is RAG the secret sauce? RAG is one solution. RAG is very widely used. So it solves a certain set of use cases, quite kind of some of the most common use cases we see these days, but it's not the only way to do AI.
All right, I think we're down to just one or two. Is RAG extension part of Postgres standard, or will it be? Are there plans to fold it in?
Is the RAG extension, so the Yugabyte RAG extension, at this point, we're just exploring. And yeah, I would imagine we would contribute it, but we'll see. We're kind of early stage, and so we'll see where the industry takes us. But we definitely want to work with the community and be as open as we can be with this.
That's all for now. Thank you.